Hello, my name is Ardi and we are going to solve problem 2.57 from Hambley's book. So the question is solve for the node voltages shown in figure P2.57. So this is the figure and we are given that our ground is here. So let's label that. So the voltage here will be 0 and the nodes we have this V1 here and V2 is here. Okay, but then we have this 2px from the ground, so the value here will be 2px. Okay, and let's assume the direction of the current. Okay, I just follow the current source, which is going up. This also going up. And for the resistors here, I assume it's going down here, going down and going to the right, and here also to the right. Okay, I think we can do KCL at P1 and then we do KCL at P2. Let's do it one by one. Okay, let's do KCL at node P1. Okay, KCL said that the sum of the current that goes in will equal to the sum of the currents that goes out. Okay, the only current that goes into P1 is this 1 ampere current source. So I just write 1. Okay, and all the other currents is going out. Let's start from this current here. And this is V1 minus 0, which is V1, divided by the resistance between them, which is 5. Okay, that's good. And then the second current is this one. So I will have plus V1 minus 2px and then divided by 15, I think. Yeah, 15. Okay, let's multiply both sides by 15. 15. So we will have 15 on the left hand side. And then here we will have 3v1 plus v1 minus 2vx. However, what is vx? Vx is v2 minus v1. So we will have v2 minus v1. Okay, let's break it down here. So I will have 15 and this becomes 4v1. Then minus 2v2 plus 2v1. Okay, 4 plus 2, that will be 6v1. And then minus 2v2. And all of that will equal to 15. Okay. So, let's have this as equation. Okay, the next thing that we need to do is we need to do KCL at node V2. Let's do exactly that. KCL at node V2. Okay, KCL said that the sum of the current that goes in will equal to the sum that goes out. Okay, and there are two currents that goes in here. Let's do it here first. So we'll have 2px minus v2. 2px minus v2 divided by the resistance between them. The resistance between them is 10. So we'll have 10 there. And then this current here, so we will have plus 2 ampere. Okay. Oh, and this current is also goes in, right? So I will have another plus here. And that is V1 minus V2 divided by 10. So I have V1 minus V2 divided by 10. And the only current that goes out is here. And that is V2 minus 0, which is V2. And then divided by 5. Okay, let's multiply both sides by 10. Okay, I think 10 is good. This 10 will cancel each other. So we only have 2px minus v2. So I will write 2. But vx is v2 minus v1. So I'll have minus v2 there. and then plus 2 multiplied by 10, that will be 20. And this 10 here will cancel with this, so I will have plus V1 minus V2, and this will equal to 2V2. Okay, now let's separate V1 and V2. So I will have minus 2V1 from here, minus 2V1 plus V1, that will be minus V1, right? So I will have minus V1 here, minus V1. And then for V2, I will have 2V2 minus V2, which become V2. And then V2 minus V2 will become 0. And then 0 minus 2V2. Okay, so I will have minus 2V2. And let's move this 20 to the right hand side. So I will have minus 20. Okay, let's flip the sign. So I will have V1 plus 2V2 is equal to 20. Okay, now let's save this as equation number 2. But then we have two equations with two variables. Okay, see this. So I'll have this first equation, and this is the second equation. Okay, maybe we can just add them up. So we will have 6V1 minus 2V1 is equal to 15. This is the first equation. And then V1 plus 2V2, that will become 20. And we can just add them up. And we will get 7V1 is equal to 35. And so we will have V1 here is equal to 35 divided by 7. I will have 5, 4. So this is the answer for V1. But then we still need to find out about V2. Let's plug V1 here. So I will have 5 plus 2V2. And that will equal to 20. So I will have 2V2 is equal to 15. But then V2 is equal to 15 divided by 2. That will be 7.5. And the unit here will be volt, and that is the second answer. So finally, the conclusion is V1 is equal to 5 volt, but then V2 is 7.5 volt. Okay, hopefully this will help you to solve this question. Thanks, and see you in the next video, I guess. Bye bye.